Let's go to Lico 2484. Count palindromic subsequences. For this question, you could have a string S. It is a digit string. That means all of the characters from it is from 0 to 9. In the return the numbers of palindromic subsequences, we need to model the result. And the length is 10 to the power fourth, right? The thing that for palindromic, we count palindromic. Um, Initially, we think about is use an interval dp, right? So if we have dp ij, and then move to dp I minus one, j plus one, right? But this is an on square time complexity approaches. For this question, if this will tell you, right? So we thinking about for this question, we'll see it has a limitation. Say that this kind of subsequences has the length 5. Count how many subsequences we which has this kind of length 5, right? So if it limited the subsequence to be length 5, we know, for example, this one and this one, right? For example, it has a pattern X, Y. Then this one can be any character, and this one can only be Y and X, right? That means these subsequences is and this kind of combination is only 100 combinations, right? And for this one, it can be 0 to 9, right? 0 to 9. So actually, this subsequence is only 1,000 combinations. So we can try to see uh, only 1,000 combinations, right? So if this question can be transferred to be, for example, we iterate this kind of 1,000 combinations, how many subsequences of a string, right? So if we iterate this kind of 1,000 combinations, subsequences, for example, 1, 3, 1, right? Then we'll see these subsequences will be 1, 3, 1, 3, 1, right? So if we have a string S, it asks how many subsequences 1, 3, 1, 6 matches this one, right? Then we can use n multiplied by 5 dp to do this, right? So the concept is that if this is fixed, right, is that we can have dp n multiplied by 5, right? That means at index I, we match the subsequences of this kind of length 5 to index j, right? So we'll see dp ij will be equals dp I j minus I minus 1 j, right? So how many and at least be this, right? And if this kind of I at index I, the character it happens to be equal to character j, then it will be plus dp I minus 1 j minus 1 on the condition that these characters are same, right? Um, so dpij will be represent at index I. It can be how many subsequences before smaller equal to index I, which matches subsequences j, right? Um, it there is another concept is that for the dpij, we should represent uh, smaller equal to I, how many subsequences matches to j's indexes, right? We should not use there is another DPIG representing set it and use the character I. For this one, because we need to sum up all of the 0 to I minus 1, j minus 1, right? In that case, dp become n square again, right? So we should use a dp concept that is smaller equal to I. How many subsequences match to index I? So if, for example, this kind of x, y, z, y, x, they are fixed, right? We just use a dp n multiplied by 5 uh, size dp to calculate what kind of sequence is this, right? And now, and of course, we can have 3 for loops to have x, y, z, and have this one to be fixed, right? But this one, we can also use a char, right? We don't need to has 3 for loop, but if we have 3 for loop, it will get us simpler. We can use a char, right? That means this kind of character, we don't need to have array I matches this kind of sequence J, right? So that is if we have this pattern, if it equals, we can add this kind of condition, right? Or for this kind of condition is the character match, or J equals 0, 1, 2, right? Or if equals 2, right? We can also add the previous one. So for this question, we just iterate the x and the y and find how many subsequences we have for our string s. So let's write code for this. And we're going to have private static final because we want to mod int mod equals 1, 0, 0, 0, 0, 7, right? And we need a long result equals to 0. And let's change this to char array equals s to char array int I equals array dot length, right? So of course we can use for int x equals 0, x small equal to 9, x plus plus, right? And for int y equals 0, y small equal to 9, y plus plus, right? And here, of course, you can also have for z, right? Int z equals 0, z small equal to 9, right? Z plus plus. Then we're going to have, for example, char character. So we just, this will be the sequence we want to match, will be x, y, z, y, x, right? So we can write it like this. So now, if we write like this, right, we'll see those kind of x, y, z, they are fixed. So we are just trying to see for this kind of s, how many subsequences with x, y, z, x, y, y, x. Right? So what we write is we need a long dp equals new long n plus 1, 6, right? And we'll say dp 0, 0. We have actual one, right? So we can set this one as 1. Then what we do is set for int I equals 1, I smaller equal to I plus plus. Then we'll say for int j equals to 0, j smaller than smaller equal to 5, right? or j smaller than 6, right? Um, j plus plus. Then we're going to have mm, so we'll say if j is greater than 0, right? And array array I minus 1 equals this is already, let's call this pattern is j minus 1, right? Then we'll have dp um so that means that the first thing is that the dp ij we can coming from the previous one, right? We don't use character um j, right? Then if it equals, then we can contribute dp ij the plus equal to dp I minus 1 j minus 1, right? Means we are able to that means we are match. For example, we are at x, y, z, right? We at index I we match this kind of subsequences, and how many x, y, z? It can be previous how many x, y, z, and if this happen to be z, right? Then we can try to see how many previous x, y matches and contribute to this z. So this is the concept, right? And we want to mod. So should be dp I j plus this mod, right? Mod. And in the end, um, we just have for every when we end, right? We just have result should equals result plus dp and phi and mod, right? And in the end, return int result. Right? So this will be pretty much the code. The char. This is not a int, should be char, right? Let's change the home to be char. Char. Then like this, actually we can optimize this, right? We can get rid of this z for loop first, as a first optimizations. We don't need this one, right? Because we can write this. We don't need a iterate z, right? We just has a random char here. And for this condition, we just don't need to compare because for z, that means we can match anything, right? So we can also write or j equals 3, right? So that we can have two for loops. So this will be one of the optimizations. It looks better. And actually, we can do even better. We'll see this kind of arrays, right? This kind of DP, it just used from the previous I-1, just depend on the previous one, right? So so after we can of course have n 2 multiplied by 6, right? But we can get the base optimization is that we can have only long 6, right? But because it depends on the previous one, what we need is that we need this kind of G to be reversely to to iterate. So what we have is J equals phi J greater than 0, J minus minus, right? Then we're going to have if this one we don't need the dimension of array I should be this one. And every time we don't need the first dimension, right? So this will be another optimizations. So this one we don't need this anymore, right? Because it is coming, the value is kept. So doing like this, we'll see it will be 100 multiplied by n multiplied by 5 or multiplied by 6 or whatever. Multiplied by 5, right? 500 multiplied by n time complexity. The space is very good. It's only only 6, right? And we can also write a Python code for for this as well, right? So we're going to have mod equals and we need um result equals 0, right? And let's have n equals its length. Result to be in length s. Okay. So for x in range n, right? For y in range uh this we'll put this one as integer. Should be, let's use integer as well. So we're going to have dp equals this one multiplied by 6, and dp 0 equals to 1, right? Then we for I in range n, we are going to have for example, we'll have for j in range 5, 0, -1, right? So I say if uh, j greater than 0 and um, and s uh, si equals um, let's have a chariot pattern equals uh, x y 变成 zero 来 y x if si equals pattern j minus one or j equals three 来，另外还有 dp j equals dpj plus dpj minus one and not self dot mod. Right. So in the end, we are going to have a result plus result plus dp5 self dot mod. Then we just return result. So this is in range return result. Oh, do we if we should have parentheses here equals dpj equals self the mod result. dp this is one. Uh, this is should be not s, right? Because this is character. So we're going to have ord minus ord a, right? Character. This zero, sorry. Okay, so doing like this, we already analysis time complexity will be um O n time complexity, right? Space is only only six.